taste it.
So what do you think your blood's gonna be like?
I don't know. I hope that it looks good.
We should turn the camera around and watch it when you say that. Oopsie. That one's done.
It looked good last time.
Okay. Well, we don't know what you've been through since last time.
I've definitely been through something.
Blood color looks pretty good.
It came out.
The spread is pretty light except for that dark spot. Just touch it, it stays. So there's a dark spot associated to it. So at least some of it is a little more dense than others. Let's go here. Oh, okay, good. It almost didn't open there for a second with the new operating system reboot. This needs a little drop of oil too. Just so we get a nice bright light on the, oops, come on. Open. Okay, so now we'll put this over there. Software's booting up.
I've definitely been through a whole night. That was, yeah.
It's looking very good. Despite your whole night of whatever that was. These are all stem cells in the background.
It looks a little bit more, they're clustered together.
This is not a real cluster.
Okay.
Just because, you know, almost touching and is not really a cluster. You have to account for some of the blood actually just coming out of you to cause a little bit of trauma. This is really good. You know, the cells are mostly open. I'm not seeing, you know, there's very little sort of bacteria associated to the cells themselves. They're nice and clean. They're well shaped. You've got a virus or a type of bacteria in that one. That's one. That's probably a viral type cell.
Mm-hmm.
But besides that, everything looks, this one's a little abnormally, you know, shaped, size. If we look around, these are types of immune cells. That guy is actually a group, it could be a small parasite, but there is some stem cells in there, that's why I'm saying that. That could be a little bit of a virus. But compared to how we've seen you in the past, this is probably one of the better samples we've ever taken.
Yeah.
So if we go to the sides, take a look what's on the sides. You've got a set of virus types. It could be, you know, this is also certain types of bacteria can look like this. It's a little bit spiky, it's a little tough to tell, but that's like way on the side. These look a little viral, but this is at the edge. Everything else looks great. This is, again, probably the best sample.
Yeah, a few weeks ago, every single cell was viral.
Yeah. There's a spot here this is that edge that I was telling you about. There's an edge of inflammation, and I wouldn't take it terribly seriously without taking a couple samples because it was just a spot. But there is in this sample some, you know, evidence of sort of bacteria, old bacteria, and some sort of oils associated to that kind of thing.
Okay.
These look decent, but they're attached. As they get closer to the center, they become unattached. The majority of your blood is super clean.
Yeah.
And, you know, like, that's a mostly dead parasite. This is up top, part of that area that's like kind of funky. But I would say, you know, a large percentage, like you can say this is some real clumping. This is more of a pattern that's a little bit of clumping with a little bit of cells that are open. But in general, most places I look have a touch of virus, which we can give you the antiviral nasal spray, a touch of some parasites, but not a lot. And if we look at sort of your global parasitic count, which is the white spots, not the big white lights. There's some in there, like 1, 2, 3, 4, 5, 6,
Right.
7, 8, 9, 10, 11, 12. Less than 20 for this one slide, so that's 200 times 9,000. So it's like 180. I think it's, what is that? Alexa, 200 times 9,000.
I can do it. It's
Yeah, where's
One-
the decimal?
1,800,000.
Yeah, that's right. You got the
Yeah.
decimal right. Good. So, but they're even not, if we really look at that, because that count isn't small. But if you look at these, most of the lights as you turn it down are empty. You know, most of the white spots are, these are all like mostly, these are not well parasites. So if I take a bigger one, for example, and if I can move him over, no, okay, there's another one. Let's use this one as an example. It looks really bright here, although out of focus, but it looks really bright. And the way you would kind of interpret this guy is to turn the light down a little bit, and then you can start to see the differences. And I'm saying light, it really means sensitivity. You can already start to see as you turn it down that the living part is the really bright area, and that icy part is the more dead area. And the way you can tell for sure is you get closer to it. The other part is that even around the parasite, the cells look pretty good. I think it was underneath. Let me see if I can, yeah. So if you look at this guy, you can see most of it is clear. You can see stem cells on the parasite itself, okay? And that's probably either a weakened part, or it's hard to tell. I'd have to really just kind of focus on that. The yellow is sort of uncommon, but it's more alive than the clear part. All this clear part is, you're seeing plasma behind it. So it's broken up actually, this, and there is some stem cells that are still deciding to be attached to it for now.
Yeah.
But all this area in here that's sort of icy, glowy, just a little bit, is dead. And then the outside part here has some energy to it. So it won't be long until this one breaks down. We have another similar thing over here where this is mostly see-through. So this guy's a good, 60% not there. But when you turn up the sensitivity, you can start to get a picture of what's left energy-wise. So maybe that's 60% alive, but not very, because that would usually be super bright. And that's an immune cell right there. Immune cells, when they're really happy, kind of have those 3 holes in them, kind of look energy-wise. Now, a lot of microscopes will see shape and not see what we're seeing here, is that the white blood cells themselves have an energetic signature pattern. And I say when they're happy, you start to see these smiley faces, in this case, it's upside down. He's also more of like a scream face, but there's lots of healthy stuff in here, and even your parasites aren't doing really well. So we'll give you an antiparasitic again, just to keep managing those to disappear, because you can see this is literally breaking apart. And once this breaks apart enough, this will literally just disappear. And these parasites in general, if you go to a live blood analysis course, they'll say a typical dark field microscope doesn't show these, it just shows the shape, and they consider it things like cholesterol or large white blood cells or anomalies, and that's how you're trained. But when what we did is, from a software perspective and a camera sensitivity perspective, and it took us a long time to perfect this, but what we're actually doing is we're reading not just shape but energy. We're actually seeing all shapes through energy in this case, and and once we understand the energy coming off of things and see the signature pattern of worm parasites, which is well described in the medical literature, and then you see something that's shaped differently that was an anomaly, and the worm parasites have stem cells on it, and these anomalies have stem cells on it, and when you're looking at the energy of them, that they're equal, that's how we've learned that these guys here are a parasite. And this will show up on a normal live blood analysis as an anomaly, and it'll look like it's sort of just a thing. Some people might say it's not even alive and it's cholesterol. Some might say it's a white blood cell. There's a big difference. So here we have a white blood cell next to this anomaly, which is actually a parasite with tons of stem cells all over it. These are, what you would see these in V-cell, like Dr. Todd's V-cell treatments. You would see these types of stem cells all throughout the body. You'd see these are essentially well-developed stem cells that are the prevalence in how these are taken up is more so here than in any other place in the body. You'll find more stem cells in parasites than anywhere else in your body. So having them, to me, in my interpretation, is you're basically taking away your life force with parasites if you let them live. And this shape and living parasite is exactly what we're finding in every sample of water.
Yeah.
Anything from $10 bottles of Icelandic, glacial, flown in. This is pH balanced, and then you've got samples that come from Elan's. Elan's living water that's $600 a month. Mariana's $17,000 filter that took 4 years to pay off. All of them. That one actually even has larger parasites than most. So we think that it's possible that a lot of these filters are taking out the things that hold the parasites from living, like minerals might be very helpful, because one of the craziest amount of parasites is where I didn't expect, which is in distilled water. So, the fact that they're steamed and they're heated and it doesn't matter. It's like without minerals, they tend to grow more. So we haven't found a water supply so far that doesn't have living parasites in it. So we're all drinking our parasites. We're drinking our parasites. And when you're being told by medical professionals, drink more water, they have the idea, but the application in today's world, at least in the United States, and even in imported water, I know that guy too, Glacial. I know Mark Glacier, that started that company. He sold it. I think that's owned by Coca-Cola now. But anyway, not Mark's fault, not Coca-Cola's fault, nobody's fault. But it turns out that so far every water type we've tested has basically what this looks like, in this, which is your sample, would look like a parasite like this. And not only is it parasite ridden, it'll have stem cells on it so that we know that they're living. It has energy coming off of it so that we know that they're living. Think about how long, a water source takes to get to you. We don't know what parasites they came from, what beings they came from, or what animals they came from, or what fish food they came from. But these parasites exist, and it's the same ones that we're seeing inside the body that traditional mycopatry says to ignore, or something else. So,
can we look at a sample of blood that's a little bit worse than mine?
Yeah, I can show you ones from the last 24 hours or last 48 hours, and you'll see some stuff. So this one is actually a pretty good sample.
That looks like mine.
I don't think it is, or maybe it was from yesterday. This is somebody's blood yesterday with very deep inflammation and clumping, and there's this white glow in it, which is probably some sort of treatment that they've had, but it can also be oils. This is a parasite that's inside this person, and then we have, let's go down a ways. This is actually post some treatments. You can see that the white blood cells actually show up as blue in this case. When they're really fully charged, they show up as blue. This is a parasite in white. These are white blood cells here. These are other immune cells here, but the cells look really great. But these are post-treatment. This is probably pre.
That one at the bottom looks...
Yeah, we're heading there, right? Yeah, this is probably mid-treatment. And then this is, sort of like not unusual in somebody coming in for the first time. Their immune cells actually look pretty strong. They're kind of circular. This one has that little 3-eye thing going on, barely. You've got another one down there that has it. Oops, excuse me. You can kind of see it's kind of cool. It's like this little alien, if you visualize the 2 eyes and a mouth. And then, so this isn't a bad sample, but this can be cleared up pretty quick to get a lot more energy in the person and less anxiety and stuff. And then this one is a particularly challenged version of inflammation. And then there's also viruses that you can kind of start to visualize inside the mess. And the misshapen part is often either really chronic inflammation, or my guess in this case would have been there's a lot of virus in here. if you believe in the whole viral thing.
And that blood, that person might develop cancer.
Well, yeah, we have to be careful what we say about that because we don't have outcome studies or anything. But what I've seen is, for example, if we look at somebody with prostate cancer, we just use this as an example. This is somebody that when they came in at 140, they had prostate cancer. They were actually treated with radiation, so recovered from that, but the blood still had this really deep rug-like clumpiness along with this red inflammation through it. Again, this is all stuff that we pick up very uniquely with our microscope. This isn't typical dark field. You can notice on the cells themselves, like the stack ones here that are like coins, the edges don't even show enough energy to show up. So this is somebody that has some cellular energy problems. There's also a real susceptibility to parasitic worm implementation, let's just say infection inside the cells, because when those ice type parasites, as I call them, start to die off, they put little worms inside the red blood cells, and I think that strategy is just to keep the immune system from killing them off while they're incubating. And you can see them in the cells too with different types of filters. And but anyway, so this is that deep sort of clumping together where, and if you imagine an immune cell showing up, it has to touch each cell in order to do its job. So this stuff is untouchable. So if you've got untouchable clumps of blood like this, you can imagine what ends up happening. And this is overdense. So the cost to the body is the body has to give enough energy and management of the cells regardless. But if your cell count's higher, that means you're putting more energy into it. But these cells aren't functioning. You know, if you have like a red blood cell by itself with plasma around it, it's going to be able to sort of do its job because it's transferring oxygen and carbon dioxide, processing, doing those things in plasma. But here they're clumped on top of each other, so they're basically smothered. And another example was somebody that came in with freshly diagnosed early Alzheimer's. Not necessarily this pattern, which you'd say is like could lead to what you're talking about, like maybe cancer or something. And again, this is just impression. This is my interpretation. This isn't, I can't show you the studies that show outcome that prove this. So this is just through our own interpretation. So I want to be really clear about that. So, but if you look at this case, this was somebody that came in with a fresh diagnosis of Alzheimer's, and this was in the morning. Oh, that's the post. I don't want to give the post away too soon, but I just gave away the post too soon. So this is where she came in the morning, and you can see the white blood cells here. Again, this microscope is very unique. It can show that these white blood cells don't have a lot of energy because the energy is by the color and the brightness, and it starts off with black, gray, white, and then goes to blue. So these are not blue. They're not white. They're almost not gray. So the immune cells are affected, and we do see that in people that have taken certain types of treatment, which I don't want to say on camera. But if they decided to do that, during recent times, I see this immune cell type right away, and I can kind of tell, the person's part of their history just based on that. This is another immune cell. It's very unusual. It kind of looks like a planet or a moon. It's textured and it's tight. Typical white blood cells will have this sort of dust coming off of it or look like a cloud. So this immune system to me doesn't look normal, and the blood stacking is so tight that I can't imagine it transferring oxygen really well. So this was a brain impaired person, and her blood looked like this that morning. She was also afraid to go outside. She asked in order to come here that I be the only one in the space, so she'd only have one human to deal with. So she was somewhat agoraphobic, not that I'm diagnosing, but that's my sort of the closest word I can use that tells about her experience. And that was, file says 2:39 in the morning, 2:39 in the afternoon, excuse me. And then at 7:03 the same day, after we cleaned that up, that was the result. And
that looks pretty good.
It looks pretty good. The only thing it's missing that I wish we would have had is what the immune cells look like. But the immune cells, I could tell you, we're looking either white or blue. And I don't really have that. Maybe I do. let me just take a look at, let me just grab some of the post so that we can kind of look through it together and see if there's any immune cells in there. So there's this, there's that. These are some immune cells, but not typical white blood cells. Same. There's a lot of what you're seeing in the background is actually stem cells as well. So it was a good stem cell trigger. This was her parasitic count, which is actually pretty darn low at this point. You can see all the cells are separated at this level. Here are some ones earlier in the day where we're starting to see openness, but some abnormalities. You know, it's so funny. We don't have any. I don't have any with the new sort of immune system cells. This is at 4 in the afternoon. Let's look at this set and see if we find anything. So we took throughout the process. So you can still see some of the old clumpiness as we're going backwards. We're starting to see that as an immune cell as well. It's larger and at least a little better lit. Another one down here, you see how they're at least starting to look a little softer. Unfortunately, I don't have a really charged, beautiful cell. Here, she was going through some viral. Through the process, when we started opening the cells up, then we saw this sort of spiky viral that was inside the clumps as we were pulling it out. So then that was like worked on with antivirals. And then that's when she started to have the cells have their normal state. Anyway, so that's one example. So you asked specifically about cancer. You know, like I'm not a specialist. I don't claim to be. You know, my thing is I just do natural remedies to help clear out the blood. But in this particular case, that woman, she traveled from April 27th until now. She's traveled 8 times, several times out of the country, and all by herself. So, and she comes in here, and I don't know if you've even met her, but she's, you know, 77 years old, and she's got the soul of a 20-year-old, and she's clear as a bell these days. So, so that's that. I mean, we've got a lot of stuff like that we can share. But if we go back to you, we have this little parasite dude to take care of, and which is just, you know, you've got 1 point something million, but most of these are dead, which is, or at least mostly dead, which is why you sort of have your clarity and the cells are looking good. A lot of times when you have living parasites, you'll have a lot more of this, which is a viral cell that show up next to the parasites. It's like, you know, maybe it's draining the cells, or it's actually helping perpetuate virus. We know that parasites are linked in medical literature to viruses. We know that they're linked to cancers, depending on the study that you look at. This could be a parasitic worm inside the cell itself. It could also be part of the red blood cell. Like this one is you know, normal part of the red blood cell. With the way we're looking with this particular filter, I could pull out and get different filters and change the camera software and settings and find out exactly what that is. But to be honest, it's not something I focus on or care about. What I care about more that we can do very uniquely compared to others is look at the energy. And you know, and you can look at these cell linings and see that the energy is very consistent. It's not like that one where you couldn't even see the walls. So, you know, the idea of this parasite as it dies off, impregnating these cells, it's going to be less likely. And it's interesting that it's got the white blood cell looking right over everything, just to, you know, almost like I don't know, like a police officer there just waiting for something to happen. But that cell would need some support probably in order to process back to normal. Anything you see these little jagged edges like this, it's, even though it doesn't show as a viral cell, it's affected in some way. We see that sort of pattern in major bacteria infections, like, you know, Lyme disease, for example. You'll see the shape. This is not Lyme because you would see lights inside the, you know, the cells itself. And if I'm mentioning Lyme, I want to see. We recently had, excuse me, some cases of Lyme in the last couple days, for example, and I can show you what that looks like. It's actually really interesting and very complex. Let me see if we can kind of go back and I can show you like pre and post Lyme. This is part of it right here. So this is, the sensitivity was really high, so some of this is a little hard to understand. But when you look inside these cells, you're going to start to see these dot patterns. This also could look viral to the naked eye, but when you understand the patterns inside and how they, it's different. Some look like worms, some have circles, and there's 5 or 6 circles. This is a worm in a circle. The fact that there's multiple different types, often there's about 15 different types of pattern that goes on. It's pretty easy to see that all these cells are affected, and that's the kind of thing that we see. Now, it's not always that many, but it's a lot. Here's another one where sometimes you're in the corner of a slide. This is like the oil, but you can actually look at these patterns really closely. Let me go back to this one. I think I moved slides rather than zooming in. You can start to see, this pattern of like 5, 6, 7 dots and other things inside the cell that are abnormal. This is, in my interpretation, again, not diagnosing, but this is what Lyme would look like. And if you were to do dark field Lyme disease and take a look at some of the sort of advanced imagery that they have, you'll see this kind of like pattern, and all these cells will look wacky, in their shape. So I can only imagine how dramatically they're affected, because they can't even hold their shape. And you see that in some of the areas where you can see like a non-affected cell next to an infected cell, you can actually start to see that the shape holds.
Yeah.
But as soon as you have a worm or these dots inside of it, you have these misshapes happening. And this is very, very, and what's interesting is that in the background, you see a lot of stem cells. You can't tell. I know them because of the colors, but if you're looking at live energy, I don't know how to call this mycopatry because it's new. But if you're looking at energy, you'll actually see these things are turning, and there's like a light pattern coming out of them. It's almost like a radar where it's searching. It's super cool. But these are all stem cells in the background. So this person has lots of stem cells. In a lot of ways, has a great jump on life. But the problem is that they have this very pervasive infection. This cell right here is showing a need for iron. So you see that in anemia. And it's just these little ridges at the end, this little nub, when you see that, anemia is also involved in this, which isn't uncommon that I've seen that in Lyme. This is another example of that as well. So anyway, and just to say one more time, I don't diagnose, I'm not a doctor, and we don't give medicine here. This is all about natural remedies and just helping people be the best that they can be. That's it. So yeah, this is just one in the last couple of days. And then afterwards, when we were done, that's in the middle. Let's try to figure out the one, that's pretty much kind of how we ended with that person, is that there was no evidence on the screen for this particular area and drop of the blood. And we did look at the entire slide, which is like 100 of these, and we didn't find any evidence of that other pattern in that person. And that was, it was within 24 hours. I'm not sure if it was a one-day thing, or one of them we did overnight. We actually did a full night and day, because when the cells are clumped, it's really hard to see what's on the inside. In fact, their partner had clumpy cells, and it took us like 12 hours just to get them open so we could see it. And that partner also had a lower level case, but also had cells in that Lyme pattern. So, and I'm not even sure we got her in time. But for him, we were able to clear it before the cells closed up. For hers, it closed up. We couldn't get a solid picture before it closed up. So we have to assume it could be there. And it can literally take 12 hours to get open again. And then you have about 12 hours to essentially correct the issue before it closes up. You didn't ask about Lyme, but you wanted a video. You wanted a video, and it's a good training.
Yeah.
And there you go. And again, I don't know, for the sake of my son, I'll say I don't know everything, and he constantly tells me I know nothing, and all that's true as well. So take everything with a grain of salt. And this is like a house of learning, but we do have a lot of videos of people whose lives were changed. So we keep doing it because it seems to help.
Cool, man.
Thank you, Kenyon.